So now we're going to look at problems that are really similar to that classwork from yesterday, but we're going to have to actually go further and write them in standard form. So my first one, using the two functions for this section, is f of negative x. And we know that that means plug in negative x in for each of our x's. So that's negative 2 times negative x squared plus 3 times negative x plus 5. So simplifying on these can be a little tricky. It's super tempting to cancel out these two negative signs. Negative 2 times negative x is positive 2x. But we have to do PEMDAS and simplify in that order. So when I square a negative number, that becomes a positive number. So this piece is actually x squared. Okay, so that negative 2 stays because the exponent cancels out the negative first. Moving on, this is, if you want to put ones in, that's super helpful. 3 times negative 1 is negative 3x here plus 5. So that is in standard form, everything's simplified, and that would be my answer. Part B says g of x minus 2. So we're going to take the g of x function and then just tack on this negative 2 at the end. I'm going to put this in parentheses. It doesn't really make a difference here but we see that we have like terms here. We're not multiplying or anything. So this is going to simplify to 3x minus 9. Moving down to the next one, I have f of 5x. So now the 5x, what's in parentheses, is what I'm plugging in. So I have negative 2. I'm actually going to put this in a different color just to kind of show a little better what's getting plugged in. So I took f of x, I took the x's out, and I'm putting 5 x's in their place. So same deal as the one above. Remember, when we had to do this first, I need to simplify this first. Now this squared gets distributed over the multiplication. Another way I can think of it is 5x times 5x is 25x squared. So this negative 2 comes down. Here this is going to be a 15x. And then if we multiply this together, negative 2 times 25 is negative 50x squared plus 15x plus 5. So that is my answer for this one. The next one says negative g of x. So g of x is 3x minus 7. 3x minus 7. So all we're doing is we're tacking a negative sign in the front. Now, since it's a binomial, I'm going to have to distribute that negative sign, or a negative 1, to both of these terms. So I would end up with negative 3x plus 7. My last two, I have f of x plus 3. So now this is the thing I'm plugging in, and these you're going to see are the most tricky ones. So I have negative 2. I'm going to do that same thing where I'm going to do this in blue so we can see what's getting plugged in. So those x plus 3s are getting plugged in for the x's and f of x. Now, because this one is a binomial squared, I can't distribute the squared. I have to write x plus 3 times x plus 3. So I'm going to write that out. Here there is no exponent, so I can distribute. So this is 3x plus 9 plus 5. Now I have choices here. There are 3 things multiplied together. I can pick whichever ones I want to do by associative property first. I'm going to do the 2 binomials. Now, this is also the time when you kind of need to get yourselves to the point where you can do some of this in your head. So x times x is x squared. This 3x and this 3x makes 6x. So if you can do that part, the multiplying and the adding the middle terms in your head, that just saves you a step. And when you're getting to more complicated stuff, you don't want to have to waste your time so much. So this is 3x plus 14. So my last step is to distribute this. So I get, I guess not last step, we're gonna have one more after it. So that's distributed. And then lastly, we're gonna combine like terms. Okay, so our last one, and I'm gonna section this off. Sorry that my phone is going off. I don't wanna restart the video. I'm not sure if you can hear that, probably. So this is 3f of x. So I'm taking the 3, and then f of x is negative 2 x squared plus 3x plus 5. So we put that 3 in the front. It's a trinomial, so we're going to need to distribute. F of x is a trinomial. So I get negative 6x squared plus 9x plus 15. So none of this is new. This is just, basic algebra 1 stuff with simplifying. But now you're thinking of function notations as doing the things that you thought just happened, with basic simplifying with variables and things like that.